Next function is to count how many layers are in the tree. So layer means beginning with a root. So we have one layer. So let me mark it. So you have one layer, and then with the same level. So this is layer 2, layer 3, layer 4, layer 5, and layer 6. So we have a total 6 layers in this binary search tree. So let's find an algorithm function to count the number of layers. So in the original tree, you could do something like this: assert t1 layer count function is called, which is 6 layers. So public interface layer count const. Similarly, we have a private recursive function layer count given root of the tree. So given tree count the number of layers. Public interface layer count, which you simply call layer count with the current tree root p, and private recursive function layer count, and root of the tree is provided. Then how many layers do we have? Base case, if root is null ptr, which means empty, then there is no layer at all, 0. Else if root is the only one, so left is a null pointer, and right subtree is empty, then it's a one layer, the only node. And else case is how many layers do we have? So if I draw a picture, here's a root node, left subtree, and right subtree. And how many layers do we have? Else case, count layers on the left subtree. Suppose we have L layers and the R layers in the right subtree. Then layer of the entire tree is whichever is greater. If L is greater, then L plus 1. This one is a total layers in the tree. If R is greater, then R plus 1 is the one. So we need to find which subtree has more layers than add 1. That's the solution. So let's find the integer layers on the left. LL is a layer count from left subtree. Similarly, layers of a right subtree, layer count from right subtree. Then the number of layers is LL greater than LR, then left subtree count plus 1, otherwise right subtree plus 1 is the total number of layers. So let's test the code. So here is the test code. Compile and run. So we have 6 layers. So from the picture, the 6th layer. If I erase 2, it will be down to 5 layers. So here, let me T1 erase. Let's erase the very top node. If this is erased, the smallest value 19 will be copied into that, then there's no change in the number of layers. Then we have the same number of layers, and the rest may not work, so let me comment this out. right? Then if I erase 2, so here, let me erase 2. So the same, but if I erase 2, it is reduced down to 5. So data 2 is here, so 5 layers. 5 layers there. So we have tested it.